It is going off of last class lesson. It's not difficult, guys. It's not as hard. It's not as easy as last class, but it's not hard by any means. Like I said, this topic is very straightforward and easy. I think you're going to like it. So we're going to start by talking about linear and non-linear functions. What do we know about linear functions? We learned about them last quarter, or last topic. In order for it to be linear, it needs to be two things. It needs to be a straight line. And where does it need to come out of or go through? The 0. Yes, the origin. There you go. The origin. So, all right. Today we're going to begin by talking about constant rate of change. The constant rate of change is the slope, and it's always a straight line. Constant rate of change. It is the slope, and it is always a straight line. So I took the advice of one of my classes, or two of my classes, and said not to make the words the underlined words a different color. But then they were complaining that the straight line that the underline was too small. So I'm highlighting now. So constant rate of change is the slope, and it's always a straight line. What?
Shelly, you're not sharing your screen.
So I am. If you can't see my screen, that means your internet's glitching. So try and leave the meeting and come back in. I only say that, Kinsley, because I'm sharing it in class right now, and so I know it's sharing. All right, so the constant rate of change is the slope, and it is always a straight line. Next, let's talk about initial value. Initial is the starting value. It's always your y-intercept. Initial value, when you think of the word initial, what do you think of? Okay, that was weird. I'm not even going to lie. Like, there's no sugarcoating that. It was just weird. Initial, when I think of initial, I think of, all right, my initial price, my beginning, my starting point, were the initial amount I'm going to pay. My starting point, like a car. When you first get a car, when you're like building a car, it's like, okay, here's your base model. All right, your initial amount is this. If you add to it, your price is going to go up. Like if you want like certain features. Yeah, like a brand new car. Okay, let me try and unshare my screen then and reshare it. I want to go here. I'm going to go share screen, start broadcast. All right. Thank you, Johan. I know you could. Hopefully this will help. All right. So your initial value, that's your starting point. It is your y-intercept. Your y-intercept. We know a lot about the y-intercept, don't we? We talked about that. In our formula, our slope-intercept formula, y equals mx plus b. What is my y-intercept? B. Good. All right. Just a little review from last. And talking about it, y equals mx plus b. So our b is our y-intercept. It is also our initial value. M, that's our slope, or what we're talking about today, our constant rate of change. Oh man, Michelle can't type or write today to save her life. So our slope is also considered our constant rate of change, which makes sense, right? Because our slope is literally saying, okay, I'm going to rise and run. That's our change, right? So it makes sense that our slope and our constant rate of change would be the same thing. And then our initial value, initial to me is like, okay, that's your beginning. I mean, it's even like, does anyone know what like a monogram is? Monograms are your initials. So like that's like my mask. My mask is monogram, TSM. These are my initials. My initials are my beginning letter of my name. No, this is my monogram. No. Okay, so initial value is similar to, that's why how initial value and y-intercepts are similar. All right, so as you see, everything that I'm talking about up to this point, this is nothing new. This is stuff we did last topic. You know, I'm just maybe calling it something else, but what we're calling it is almost like a synonym for what it is. So let's talk about linear functions. Like we did, linear functions are a straight line, and they're straight due to their constant rate of change. So a linear function is a straight line due to the constant rate of change. So in order for it to be linear, it just got to be straight. Stop. Calculate kindness. Calculate kindness. Nothing. Tyler's going to find himself benched soon if he's not careful. So linear function graph is a straight line. A non-linear function, stop, graph is not, I mean, this kind of makes sense, right? If it's non-linear, not, they're kind of the same. It is not a straight line due to no constant rate of change. Clint. So, nonlinear functions are not a straight line. Yes. So, I mean, think about it. What word do you see in linear or nonlinear? Okay, so we see no, but look at just linear. What? Say that again louder. Look at that. Line. So, if it's linear, it has a straight line. Like Tyler said, no line means there's not a line there. It's a curvy, wavy, all over the place line. So tables, in order for tables to be linear, they have to have the same rate of change. Does this sound familiar? Do we remember how to find the rate of change? We've already talked about this, right? Last topic. Yeah, we found the constant rate of change. What? We're adding two things that we've already learned? Whose fault is that? Not mine. All right, so let's look at these two examples, okay? We're going to do this a little bit different. We want to make sure that my x's have the same rate of change. So what that means is when I go from one x to the next x, it's got to be the same number. So let's take a look at my x's in my first graph. How did I get from 2 to 4? What do? I add 2. How did I get from 4 to 6? How did I get from 6 to 8? All right, so my x's so far are good. What about my y's? How did I get from my first y to my second? I had 5. Okay, how did I get from 10 to 15? How did I get from 15 to 20? So does this have a constant rate of change? Yes. All right, so now let's take a look at my second one. Okay, so how did I get from 1 to 2? How did I get from 2 to 3? How did I get from 3 to 4? All right, now let's take a look at the bottom. How did I get from 4 to 8? How did I get from 8 to 13? Uh-oh. Is that constant? So is that a linear? No, it's not. I told y'all Did I tell y'all? So this is linear, and this is nonlinear. I forgot to label them. You should label them underneath on the line provided. All right. We ready to look at the next one? Okay. It says two linear functions are shown below. Which function has the greater rate of change? Okay. So we're going to look at rate of change. We're going to look at our y's. How did I go from 32 to 44? Okay. Double check. Is 12 plus 56? Or is 12 plus 44 56? Okay, so my rate of change for A equals 12. How do I figure out what my rate of change is for function B? Yeah, I need to put my dots right and see what my slope is, correct? Because when I'm looking at my rate of change, my constant rate of change is my slope, correct? Yeah. So we're gonna say that my slope is here at 3. It looks like there's another line. It looks like it crosses around. Well, actually, my slope is a little lower. Say right about there. Where does it cross again there? Looks like up here. Okay, so how did I get there? So 1, 2, 3, 4. What? Did it go 5? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my constant rate of change here would be 5. 5 over 5. So what has a greater rate of change? Function A. We might be a little off with function B. It's not 100% 5 over 5, but. All right, let's take a look now at our second problem. It says two linear functions are shown below. Which function has greater initial value? Okay, so remember, initial are my x's, constants are my y's. Okay, so when I'm looking at function A, y equals 3/4 x plus b. What is my initial value? What's my initial value? Jade? 5. Good. So my initial value for function A is plus 5. Now, remember, initial value, you look at your y's. So let's take a look at my y's. What's my rate of change for my y's? 3, right? Because 5 plus 8 is, or 5 plus 3 is 8, 8 plus 3 is 11. So this is plus 3. What's bigger, plus 5 or plus 3? So function A. All right, let's now take a look at the next one. Now it wants to know whether each function is linear or non-linear. So let's take a look at which function is linear or not linear. All right, so how do I figure out if function A is linear or not linear? What do I need to do? Colton. Okay, remember, x's are my initial, y's are my constant. If it's linear, I need both of those to be constant, right? Yeah, I need both of those to be the same. So how did I go from -2 to 1? Add 3. Okay, did I add 3? Yeah. Okay, sorry, I couldn't remember. Okay. Yep, so I'm only adding 1. Okay. But down here, I'm going from 3 to 0. So what am I doing? Subtracting 3. Okay, but then every other time I'm subtracting 1. So it's the same here, right? So is that linear or nonlinear? What is it? Why is it nonlinear? Yeah, there's no constant there, right? I don't like writing it that big. I don't know why I did that. It's not constant. I mean, it's constant after that first example, but before that first example, it is not constant. All right, let's take a look now at function B. Function B is a little tricky. I want you to take a look at function B. Don't say what you think it is out loud. Just take a look at it. My online kids and my in-class kids, this is what I want. If you think it's linear, you're going to hold up 1 or type 1. If you think it's nonlinear, I want you to hold up 2 fingers or type 2. So 1 for linear, 2 for nonlinear. I'm going to give you a second to take a look at it. 1 for linear, 2 for nonlinear. All right. Thank you, Kinsley. Thank you, Johan. Thanks, Anna. Thanks, Jenna. Thanks, Connor. Thank you, Camilla. All right. How's my in-classes? I don't see every hand up. Awesome. Ty's even participating. Ty's like, I'll do this lesson twice. All right. So it seems like the mass majority said that it was non. Who can tell me why it is non-linear? Why is it non-linear? Jocelyn. Because my line is not straight. Great. My line's not straight. This little curve right here. Actually, I don't like doing it that color. Let me go to highlight. This like curve thing happening here. That is not straight. So it is not linear. All right, let's take a look at this last one. I want you to do it on your own paper. I'm going to give you just a few minutes. Decide whether each function is linear or nonlinear from the graph. I'm going to give you 1 second to figure out if it's linear or nonlinear. Who brought me these wonderful forms? Ooh, who has the good forms? Ooh, Miss Delgado, she got the bougie ones, the non-printed. Thank you. For your troubles. Said for your troubles. Yeah, for your troubles. No. It means for walking up the stairs, honey. I know. I know. They did. Are we all done? Boys, did we finish this? Okay. What did we get then, since we're all done? We're just so smart. Is number 1 a function or not, or is it linear or nonlinear? Why is it nonlinear? Right, because it got this little curve. It's got like a smile. All right, what about number 2? Is number 2 linear or nonlinear? Why is it linear? Because it's a straight line. Look at that. That's straight, so linear. Oh, all right. This next one's a little tricky. Is it linear or nonlinear? Okay, Tyler, why do you think it's not linear? Keep going, keep going, keep going. Yes. Yes. He's right. It's not linear because it's not a straight line. Like, look right here. It turns into like a V shape. It is non-linear because a straight that's not straight, right? That's like it's like crooked. Like it needs to be like straight. Yeah. So it is non-linear. All right, good job, guys. So let's talk about today. I'm gonna go ahead and stop recording. All right, give me a second, please. So we can stop recording.